What if I told you that this seemingly complex integral has an incredibly elegant solution that you can solve in just one step? The answer is simply sec of x plus c. That's it. But how do we know this and why does it work? In this video, I'll show you exactly how to master this integral using 3 different methods, and more importantly, help you understand the beautiful mathematical reasoning behind it. Today we're exploring the integral of secant x times tangent x. This is one of the most elegant integrals in calculus because of its direct connection to derivatives. By the end of this section, you'll understand not just how to solve this integral, but why it works through the fundamental relationship between derivatives and integrals. The key insight that makes this integral so elegant is understanding the relationship between derivatives and integrals. Let me show you what I mean. Remember that integration is the reverse of differentiation. So if we know that the derivative of secant x equals secant x times tangent x, then we immediately know our integral. This is the fundamental theorem of calculus in action. The integrand, that's secant x times tangent x, is exactly the derivative of our answer, secant x. Now that you understand the core concept, we'll explore 3 different methods to solve this integral: direct recognition, substitution, and trigonometric identities. Each method will deepen your understanding and give you multiple tools for similar problems. Each method will not only show you how to get the answer, but will also build your intuition for recognizing similar patterns in other integrals. Ready to dive in? The most straightforward method for integrating secant x times tangent x is direct recognition. This method relies on recognizing a fundamental derivative pattern that you should know by heart. Step 1. Recall that the derivative of secant x equals secant x times tangent x. This is a fundamental trigonometric derivative that appears frequently in calculus. Step 2. Now we apply reverse thinking. Integration is the reverse process of differentiation. If we know that the derivative of secant x gives us secant x tangent x, then working backwards, the integral of secant x tangent x must give us secant x. Step 3. We can now write our integral. The integral of secant x tangent x dx equals secant x plus c. The c represents the constant of integration, which is absolutely essential and must never be forgotten. Remember, the constant of integration is crucial. Every indefinite integral must include this constant because there are infinitely many antiderivatives that differ only by a constant value. This direct recognition method is the fastest and most efficient approach, but it requires you to have your trigonometric derivatives memorized. The key is recognizing the pattern immediately when you see secant x tangent x in an integral. Now we'll solve the same integral using the substitution method. This approach will help reinforce your U substitution skills while showing how different methods can lead to the same result. Step 1. We choose our substitution. Let U equal secant of x. This choice might seem obvious now, but recognizing good substitutions is a key skill in integration. Step 2. Next, we find du by taking the derivative of our substitution. The derivative of secant x is secant x tangent x, so du equals secant x tangent x dx. Notice how this matches our original integrand perfectly. Step 3. Now we can rewrite our integral. Since du equals secant x tangent x dx, our integral becomes simply the integral of du. This is the power of good substitution. It simplifies complex expressions. Step 4. The integral of du is simply u plus the constant of integration. This is one of the most basic integration rules. The integral of a variable with respect to itself is just that variable. Step 5. Finally, we substitute back our original expression for u. Since u equals secant x, our answer becomes secant x plus c. We've successfully solved the integral using substitution. Here's our final result. The substitution method gives us the same answer as direct recognition. The integral of secant x tangent x dx equals secant x plus c. This method is particularly valuable because it reinforces the systematic approach of U substitution that you'll use throughout calculus. The substitution method demonstrates why understanding derivatives is so important in integration. When you recognize that the derivative of secant x is secant x tangent x, the substitution becomes natural and the integration becomes straightforward. Now we'll explore the third method for solving this integral using trigonometric identities. This approach breaks down the secant and tangent functions into their basic trigonometric components. First, we need to recall two fundamental trigonometric identities. Secant of x equals 1 over cosine of x, and tangent of x equals sine of x over cosine of x. Now we substitute these identities into our original integral. Secant x times tangent x becomes 1 over cosine x times sine x over cosine x. When we multiply these fractions, we get sine x in the numerator and cosine squared x in the denominator. Now we can use u substitution. Let u equal cosine of x, which means du equals negative sine of x dx. Substituting into our integral, sine x dx becomes negative du, and cosine squared x becomes u squared. This gives us the integral of negative 1 over u squared du. The integral of negative 1 over u squared is positive 1 over u plus the constant of integration. Finally, we substitute back u equals cosine x to get 1 over cosine x plus c, which is exactly secant x plus c. This trigonometric identity approach demonstrates how breaking down complex trigonometric functions into their basic components can make integration more manageable. We used fundamental identities and u substitution to reach the same result as the other methods. Now that we've learned the methods for integrating secant x tangent x, let's apply our knowledge to solve a concrete definite integral problem. We need to evaluate the definite integral of secant x tangent x from 0 to pi over 4. Step 1. We need to find the antiderivative. From our previous work, we know that the integral of secant x tangent x equals secant x plus c. This gives us secant x plus c as our antiderivative. Step 2. Now we apply the fundamental theorem of calculus. For a definite integral, we evaluate the antiderivative at the upper limit minus the antiderivative at the lower limit. This means we evaluate secant x from 0 to pi over 4. Step 3. We need to calculate the secant values at our limits. Let's evaluate secant of pi over 4 minus secant of 0. This gives us secant of pi over 4 minus secant of 0. Now we need to evaluate these secant values. Secant of pi over 4 equals 1 over cosine of pi over 4, which is 1 over root 2 over 2, giving us root 2. And secant of 0 equals 1 over cosine of 0, which is 1 over 1, giving us simply 1. Step 4. Now we can complete our calculation. Root 2 minus 1 gives us our final answer. Therefore, the value of our definite integral is root 2 minus 1. This equals approximately 0.414. This result represents the area under the curve of secant x tangent x from 0 to pi over 4. This area calculation demonstrates the practical application of our integration techniques. We have successfully solved our definite integral problem using the antiderivative we learned earlier. This example shows how the integration techniques we studied can be applied to find exact numerical results. Now that we've learned multiple methods to integrate sec x tan x, it's crucial to verify our results and avoid common pitfalls that trip up many students. The most important habit in integration is verification. We always check our answer by taking the derivative and confirming we get back to our original integrand. We start with our result. The integral of sec tan x equals sec x plus c. To verify this, we differentiate our answer. We apply the sum rule for derivatives. The derivative of cx is sec x tan x, and the derivative of any constant is 0. Perfect. We get back exactly our original integrand, sec x tan x. This confirms our integration is correct. Now let's examine the most common mistakes students make with this integral so you can avoid them. Mistake number 1, forgetting the constant of integration. Remember, indefinite integrals always need plus c because there are infinitely many antiderivatives. Mistake number 2, incorrect derivatives in substitution. Students often forget that the derivative of sec x is cx tan x, not just tan x. Mistake number 3, incorrect pattern recognition. Some students confuse this with the power rule and try to integrate as if it were sec squared x. Remember, we need to recognize that sec x tan x is the derivative of sec x. Here are the key tips for mastering this integral. Always verify your work by differentiation. Never forget the constant of integration. Make sure you know your derivative formulas, especially for trigonometric functions. And practice recognizing patterns. This skill will serve you well throughout calculus. Remember, research shows that nearly half of all calculus students initially struggle with recognizing derivative patterns. With practice and careful attention to these common mistakes, you'll master this integral and build confidence for more complex problems. The habit of verification separates good mathematicians from great ones. Always double-check your integration results. It will save you from errors and build your mathematical confidence. Now that we've mastered the integral of secant x tangent x, you might wonder where this actually shows up in the real world. The answer might surprise you. This integral appears in some fascinating applications in physics and engineering. In physics, when analyzing pendulum motion for large angles, the exact solution for the period involves elliptic integrals. These complex integrals contain terms with secant x tangent x, making our integral essential for precise calculations in mechanics and oscillatory systems. In engineering, particularly in signal processing and communications, Fourier analysis is used to decompose complex signals into their frequency components. When analyzing certain periodic functions and solving related differential equations, integrals involving secant x tangent x frequently appear in the mathematical framework. Mastering the integral of secant x tangent x comes down to three essential approaches. First, direct recognition by understanding derivative patterns. Second, the substitution method, which reinforces your U substitution skills. And third, using trigonometric identities to transform the integral into a more familiar form. The most important takeaway is that pattern recognition is your most powerful mathematical tool. When you see secant x tangent x, immediately think about the derivative of secant x. This connection will serve you well throughout your calculus journey. Remember, mathematics is a skill that improves with practice. The more you work with these integrals and recognize the patterns, the more confident and proficient you'll become. Keep practicing, stay curious, and don't hesitate to revisit these concepts whenever you need a refresher. If this video helped you understand the integral of secant x tangent x, please give it a like and consider subscribing for more calculus tutorials. Your support helps us create more educational content. Thanks for watching, and happy calculating!